Learn C the hard way, exercise 45. We're doing another little break where you're actually going to use the ring buffer and some of the other elements of this little library you're creating to create a simple network client. So you're going to learn to use the select method and a ring buffer to write a simple command line network client. But what I'm also going to do is show you in the code review how to combine the light impression code review with the formal code review. Okay, so first off, how select works. For whatever reason, people find select just sort of strange, but it's really simple. Okay, you are creating sets. So imagine it's like, in Python, you'd create a list of all the integers that represent open files. Okay, so it can be open sockets, it can be open files from the command line, or from open functions or whatever. Because remember, within a Unix system and also within C, files can be represented by just a single number. So that's what a file descriptor is. Now what you do is you can create sets of these and then call one function that tells the operating system, whenever this list of file descriptors is active for a read, let me know. And what it will do is it will take that set and it will flag all the ones that are active for read or write or error and give a little timeout if you want. And then you can go and read from those sockets. So with that in mind, you can then do all sorts of dynamic things, but you're not sitting around, you're not like using CPU to determine, or using processing to determine if you can read from something. You don't have to poll it. Instead, you wait when the OS says, hey, you have something to read, you go and you do your read, you come back. Okay, so it's a select loop. Now I'm going to show you a project that does this in a very nice way. And I believe it's now it's somewhere else. Yes, it's here. So libuv is sort of a way more advanced version of the select loop you're going to do right here. So if you wanted to get really deep into this, you could use that. But first, I recommend you learn to use select. Now, if you're interested in learning TCP/IP program, we're going to use a lot of that at the end, and I'll mention this before. But a book I recommend is Effective TCP/IP by John C. Snyder. And Effective TCP/IP by John Snyder is a decent book. It's an old book, so some of the code is due to kind of be changed out as soon as IP version 6 becomes a thing. But it's almost like learn network programming the hard way, because he just goes through 43 kind of tips, but they're more like an exercise. And you learn network programming, and that's sort of the basics of it. So I would say if you want to get decent at this, grab that book. At the end of this course, I mention a lot of other books too. So now, with that in mind, reading through the code and going through the code, you're going to learn a lot about how select loops work and why they work. But if you want to research more, then read the man pages and grab that book I just mentioned. And now let's discuss better code reviews. Okay, so code review. The thing about code review is if you do it cold, then it's a little slower. But if you warm up with sort of an impression code review, a quick glance code review, a scan, then that makes the code review go a little slower. So we're going to augment the code review process. And I'm going to go through NetClient. And the difference is when I do a formal code review, I start at the entry point, which is main. But when I do a scan, I start at the top. And then what I'm looking for is anything weird. So I'm looking for anything where I'm doing too much stuff or I don't know quite what that is. So I'm going to start at the top. Okay, so I'm like, okay, that's okay. Now let's see, F control, got to make sure that's the thing. Okay, that's setting non-block. That's fine. I'm getting my address info. Okay, I got to confirm that pointer there. And I might drop comments for anything I think is a bug. Okay, and then I get my socket. That's my connection. Call non-block on it, and I free it. Okay, so now I'm doing read sum. That's an available buffer data. And then I commit it. Okay. Calling receive and read. Okay, oh, here's something. This is weird. Okay, why is this not part of ring buffer? Bug. Okay, yeah, so I'm not sure why I have to do that there. Why am I doing this? Why is that not part of ring buffer? Okay, because that looks weird. Why am I having to do my own, yeah, why do I have to do this? I'm not sure. Okay, so, okay, there, return that. Find and replace. Okay, yeah, so, because what I want to do is I want to replace all the new lines with CRLF and so on and so forth. Okay, so that's fine. But I'm not sure, why am I doing that? I need, I guess it's just because it's kind of a standard protocol-y thing. Okay. So write some, and that comes out there, and I'm sending on the buffer. Okay, that's fine. That looks all good. Okay, so now I'm going through main. I create a ring buffer, create a sock buffer. I do my little client connect. Oh yeah, I'm not, okay, so yeah, here we go. Bug. Check the command line args. So I need to, because I'm just using them, I should check it. That's super bad. Okay, so now I'm masking out the zeros and doing the set, and I run my select loop. That comes back good, giving me a number of selects, and then I do if it's set on read, if it's set on write. I'd call read sum, and in RB. Okay, yeah, because I'm doing 0 is my standard in file descriptor, and socket is the file descriptor I got for the socket. Okay, so that's good. And then if it's not empty, write it, and if it's not empty, do that. Okay, and that keeps going until I hit Control-C. Okay, so that's my first pass that I'm doing on this. Great. So now I can do a more formal code review. And I won't do a complete one, but what I would do then for a more formal code review, I might take some notes. I might think, okay, do I want to do the refactoring first? Like, do I want to find out why I'm doing that first, or I just want to do a code review? I prefer to actually do the code review and confirm all the fixes so that the code is solid. But if I'm going to change a whole whack of it, then I'm probably going to want to just go and do the changes and then go back and do the code review again. This is the advantage of doing an impression code review first, is I can do an impression code review and go, yeah, this isn't good. I'm going to rip this out first, and then do a formal code review and check that it's clean. Okay, so now formal code review time. Okay, so bug. Oh, hey, I actually did do it up there. Cool, all right. So that is not a bug. Let's just move that together so I can actually see it. Okay, arguments are checked. I would say, I would probably do, nah, I guess that's fine. Okay. Okay, confirmed. I'm going to do the man page, fd0, takes an fd set. Okay, that's fine. Fd set sets it all reads and all writes, because what I'm doing is I'm putting that socket into the all reads set, so it will trigger an all reads set. Okay, and I've set it to non-blocking. If is set, okay, if is set. All right, here we go. Let's check this. Come in, select on that socket. Oh, actually, I am not really paying attention. Ah, I missed this because I was talking about that bug. Okay, so jump into there. Okay, address info. Get address info. I want to check the parameters to that. It takes a host name, a server, a struct for hints, and a result. And it's a pointer to a pointer for the result. Okay, there we go. And that's basically an out parameter, that last parameter. Okay, and then I do socket. So I'm going to look up the man page for socket. This crafts a socket for me. So I want the domain, the type, and I don't care about the protocol apparently. Okay, and then I want to do a connect. So let me confirm the parameters to connect. I'm coming in and doing sock address, sock len. All right, that looks good. Sock address, sock len. Okay. And then I'm setting it non-block. So let's jump into non-block. Flags, F control. I'm going to check this. Now this is mostly just kind of socket programming lore that I'm doing here. So yeah. Okay. So getting the flags back. What happens is you get the flags back from the socket, then you OR in the one you want, which is non-block. And what a non-blocking socket does is it lets you read, but if there's no data in it, it returns right away. Or it just returns whatever data is there, so you're not blocked by it. And that's what you have to have with a select loop. Okay, so F control, That is right. Pop out of that. Free address info. I want to get the thing for it. Okay, we're good with that. And if there's an error, it returns it. Oh, but this should be if address, because I'm not sure if free address info can take it, so I'm going to do it. Okay, pop out of that. Continue on. Select. I want to confirm the select loop options. So I'm in a while loop and I'm selecting. So that's it. So read file descriptors, the write file descriptor, read mask. I'm not caring about writes, and I'm not caring about errors, and I'm not caring about a timeout value. Okay. The purpose of the timeout value, the last thing, is so that you can have a select loop that only waits for, like, say a sub microsecond or whatever, and does some other processing. And a lot of what they call green threads use this method to make fake threads. Okay. So now if is set, let me just confirm that is being used correctly. Is set takes a pointer to that. Okay, read sum. I already scanned this, but let's go look. And this is the one where I had the, do I need this? I would go and confirm, why do I need that? But for the most part, that's good. And available data. Okay, that's good. And receive. Now, on most Unix systems, you can just call read, but to be portable, you want to do receive on sockets, read on things that aren't sockets. Because there's extra flags you can pass to receive. Okay, read. I want to confirm that. And, I don't really have to confirm that because that's the common one, but keep in mind, if I didn't want to make this read sum a little more portable, because the idea was that maybe I would pull it into ring buffer and just be done with it, that's what I would write. Because if I had pulled it out, then I want to be able to have it work on files or sockets. Okay, so, and then commit write. That's all it's doing, is just moving the pointer or the end and the beginning around, and I have my error. Okay, now I jump back up. Is socket read sum. I'm doing a debug. Write sum. So write sum, I come in, I make sure that I get all the data. So I'm going to try and write it to the socket. I'm going to send it, and I check that it equals the length of the data, and if not, destroy. This is debatable. I could say that it was, if I checked it, okay, so here, let me just do this, bug. I could say instead, put unread amount back in the ring buffer. And then the other thing is I could say to do, don't use B strings, just use the buffer directly. So that's what I could do. Okay, so that's pretty much good on that. And there we go. I did a code review of the Net client. And it sort of was, even though I was talking along the way so that you don't get bored just watching me do it, it was a good strategy to do sort of a review. So that way, when I get to this, I know, hey, I've already flagged that, so I just need to make sure that I'm using that correctly. And also it helped me sort of understand the code a little bit better. Okay, improving it. These read functions are pretty useful, so I can put them in ring buffer if I want, but I keep them in this because then I show you how to use the Net client code later on to make a server. So that's useful. Extra credit, as I mentioned, there are quite a few functions you may not know about, so look them up. Go back through and add various defensive programming checks. Use get_opt to allow users to set options, and just try and do like get_opt, and do you want to translate the new line and the RN. That's a thing that happens in most protocols. Old protocols, you had to do the carriage return line feed because that's just the way all computers were at the time. But now you don't need to do that anymore. So make it optional. That's the end of exercise 45. Exercise 36 in Learn See the Hard Way is my favorite data structure, or my favorite class of data structures. I love ternary search trees. So I'm going to teach you about this data structure, but you should be able to read the code. The code is actually pretty small, and I'll load it up so you can see it because I'm going to do a light code review of it. So a ternary search tree is similar to a binary search tree. Duh. It's got 3 items. But it's based on the characters in a string. And what it does is it makes it so that you can find any one part of a string or subpart of a string from just a few characters. So anytime you have to map a small number of strings, like a small number of characters in a string, to an element, you want to use a ternary search tree. But it has other advantages. You can find any string by just comparing n characters. So let's compare those 10 characters. With a binary search tree, remember in the binary search tree, you had to do a comparison of the whole string at each node as you traveled down. Whereas a ternary search tree, you just compare each character as you go down. You can also detect missing strings as fast and usually faster. In a binary search tree, you could potentially traverse at least half of the tree, maybe more if it's poorly structured, before you figure out that this thing isn't in the tree. But with a ternary search tree, with the 3 nodes, if you're given a single character and it's not like in the tree at all, you know right away. So you can actually stop looking for that in one single move. And at most, you'll only have to scan 10 or 20 characters. You can also find all the strings that start with or contain any substring just as fast. You can find all the similar known strings quickly too. So you can use a ternary search tree to take a string and sort of like traverse it. And when you get to a point where it's sort of a dead end, you can say, well, here's all the ones that are similar to it. And you can sort of do a light traversal after that. It has some disadvantages. Deleting is really painful. So most of the time I use ternary search trees as sort of like a constant database for URL routing things. I don't use it so much as because it does use a lot of memory. So I use it mostly just for things I don't plan on deleting very much. It uses a lot of memory to store the keys. So it's bad for large sets of data, and especially large keys. So it's better for small keys and small, it can use fairly huge key sets, but, in theory, it's only for small keys. And it's also kind of weird for most programmers. Most programmers don't think of strings in terms of being able to take them and break them down into, like a tree. They don't think of them that way. So the TS tree, let me load that up, is structured like a binary search tree, but with an equals element. So instead of a left and a right, which is low and high, it's equal. And what you're doing is you say if, and I have a split char. So this is the character that this represents, and then that's a value. So if this element of the ternary search tree, if I'm traversing a character, say abracadabra, I want to find ABR. I start at the top, I go A is, and then I go B. Okay, so is B less than, equal to, or greater than? It's less than, equal to, greater than, cool. And I keep traversing until I get to an element that matches. So I go character by character. Now, you have the code to finally understand that, and the code is not very complex. It's pretty simple. I would focus on TST search as your primary thing, and prefix, the search prefix. Try and understand how those work. Okay. Now let's look at deleting. I didn't even do a delete in this because it's just such a pain. It's just not even worth it. But let's look at destroy super quick. So destroying is at least, the thing with deleting is when you remove an element from ternary search tree, you have to figure out how to rotate it up into the tree. So it's actually quicker to delete a node and then add it back in. So it's super lame, but that's sort of a faster and easier way to do it. But you can work it out. It's possible. In destroying, notice what I'm doing is I'm doing it recursively. It just seems to be the easiest way to do it, but this could cause problems if you were to do a recursive delete on a very large tree. So a good place to improve this would be to make this non-recursive. Okay, let's look at improving it. So you could allow duplicates using darray instead of a value. That's one thing. As I mentioned earlier, deleting is hard, but you could simulate it by setting the values to null. So that's another way to delete. When someone does a delete, you find the node, you set it to null, under the assumption that, well, you went through all the trouble of creating that character, and you're using small size strings, so that character is probably going to come up again. So, all right, we'll just set it to null, and then that's that. There are no ways to collect all of the possible matching values. I'll have you implement that in extra credit. What I mean by that is trivial in a ternary search tree to say find all of the strings that match a certain prefix or that have a certain suffix in them. So I'll just have you implement it in extra credit. There are other algorithms that are more complex but have slightly better properties. And extra credit, try to implement a TST correct that returns a D array of all the keys that match a given prefix. TST search suffix, that's another one. Insert suffix, that's another one. Use the debugger to see how the structure is used in memory and compare it to the BS tree and the hash map. Okay, that's the end of the lecture 46. Learn See the Hard Way exercise 47, we apply what you learned about the ternary search tree to create something called a fast URL router. So this is something you would find in, say a web framework like Django or a web server. I use this in a web server I made called Mongrel 2, and I can show you that project super quick if you want to see some code. I no longer manage it. It's actually managed by the nice folks who like to use it. .com, Mongrel 2, Mongrel 2. It's an open source project, and it was a web server that I started, and basically it's a kind of cool little web server. It's now managed by other folks, so if there's bad code in it, it's not entirely my fault. No, they're good folks. They know what they're doing. So anyways, the purpose of a URL router is when a URL comes in, you go call some sort of module to have that module run, or like a callback or a handler. So what I'm going to do is I'm going to do a quick code review of the URL router so you can see how a ternary search tree works, and you can see me do the new process you should be using, which is get an impression code review, then do a formal code review, and then make your changes. Or an impression code review, and if it's super, super messed up at that point, make your changes. Okay, the code review for this is pretty simple. So first thing I got to do is I start at my top because I'm doing an impression, and I'm looking for anything weird. Okay, so I'm going to add a route. I'm checking that. I'm checking these things. Oh, I don't really check there. All right, I'm going to have to watch. I'm not really checking the return values on those splits. So I got to confirm that. Okay. And I open the map file for the routes. All right. And I get each one. I'm not seeing anything too strange. This is a fairly small program, so. And then I match URL, search by prefix, and then read line. I'm going to come in and read the line one at a time. Okay. And I have my little destroy callback. Okay, that's weird. Why am I doing that? Oh, I'm guess so that this is... Yeah, so it's ignored. Okay. Destroy routes, traverse the tree, and destroy it. That's fine. Because I have my own destroy callback there. So, and then, because I destroy the value at that point. Now the main function, anything strange in that, checking my arguments, loading the file, doing a while loop on that. B destroy route. Yeah, so here, how do I break out of this? I guess you don't. You just hit Control C. Yeah, so bug only Control C to get out of this. All right, so that would be something I would potentially want to change. Okay, so that's my first impression. And now what I'm going to do to continue the first impression is I'm just going to make sure that everything's correctly passing a build. And I believe I have in my tests, ls test txt. Do I have any URLs? ls tests Nope. So I'm going to make a quick URL file, urls.txt. And let's do, go look at the book and see what we want for a format. I have some sample data in here just so we can run it really quick. And let's see, get the test data. Here's our tests. And what I want to do is I just want to make sure that it works the way I think it works, because that's part of this a demo of a code review process. And I'm going to get that, do that there. All right, so as you can see, I'm matching a URL to a handler. And the handler could just be some arbitrary name. Okay, so now if I do bin URL lore, let's make sure it gives me a thing. Okay, and I got my urls.txt. I can type in, and then I have things to test.html, and that matches. But if I do blah, 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 it does not match. Okay, that works. Now for the formal code review, what I'm going to do is start at the very top. Okay, I'm coming through here, and I'm going to now dive into load routes, and I'm going to confirm that it takes a string and returns a TS tree. And I come in and I'm going to do fopen, and I'm not going to do the man pages because I know these. Okay, bgets. I do want to see if I can jump to that and confirm that it takes a void parameter, a terminator, and a get string, because this is a new function. I haven't used it yet. So we're going to use fgetc to read off of the route map file using bgets, and that's going to give me a line. Okay, so I trim anything off. This is giving me each line by line, and then I close the lines. Okay, come in, and then I want to go into here, load route data. Okay, and this was something I want to do check data doesn't equal null. Bad data from B split. Okay, confirm that worked. Tests are running. And then I want to confirm TST tree. And that takes, and I'm assuming that because it's in a library, I don't have to go confirm it. I just have to look at the parameters. And it takes a node. I've got a node. And it takes a key. I've got my key. And it, and it takes a length. I've got my length. And it takes a value that I'm going to set. I got my value. Okay, great. And it returns a route structure. I delete my bstring list from there. I return routes, and if there's a null, I do that. And I should, if data bstring list destroy data. All right, so I actually just improved that too. Okay, that function is good. Now I'm coming through bdestroy, that's good. Fclose, that's good. If there's a route map, close it. If there's a line, delete it. Okay. Actually, that could be a bug. Yes, because line doesn't get set to null after this call to bdestroy. So, conundrum. I can have a check happen here and a check happen there. Where is line created? Line is created from there. So if I bdestroy here and it loops to the top, you know what, just to be safe, I'm going to say line equals null for error cleanup. Okay, so we're doing a destroy, then setting it to null, so that way when it reaches here, if it was destroyed, but there was an error, it won't actually do a double free on accident. Okay, that's a common error. And recompile. Okay, there we go with that. Okay, while one, I'm just going to assume that, okay, fine, we just wrote it this way, but now I do read line. I step into that. I'm going to do a bgets on stdin. I check debug, cool. I trim the white space on it, and I return it. Otherwise, I return null. But see right here, that could fail, and I don't free this. So if result be destroy result. All right. And the prompt is good. Okay, so now pop out of that. Good. Match the URL. Pop into match URL. I do a TST search. Confirm the parameters to TST search. I'm doing a root, a key, and a length. I got my root. I got my key. I got my length. That is good. And then I just search. If I don't find an exact match, I print that out, and then I do just by the prefix, and it takes the same parameters, and I return. There we go. There's no error checking in that because it just calls. Okay, so I print it if I found it, otherwise I don't, and then I destroy the URL that got read. So there we go with that. Now I destroy the stuff I created. That is good. This takes a tree, a callback, and some data to hand to the callback, and my destroy callback is there. Okay, and then finally come out of this, and if there's an error, destroy the route. But actually I'm going to do if routes, then destroy routes. Okay, now let's just confirm that our changes actually do something. And blah, 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 fail, blah, 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 oh, wait. Oh, that's funny. Let's go see if that's actually true. Let's see. No, it is not. I matched ASDF. It matches index handler. Oh, yes. So that is right because I'm doing just a soft match on a prefix. So this brings up something from the code review, which is I wonder if I could change the prefix so that I got a soft match. I do a flag for the soft match. That would be interesting. So let me show you that. So what is happening is I am doing the match function here. So I'm going to jump into match. Now, what happens is I search, and if I don't find an exact match, then I can do a prefix match. So what I want to do is I'm going to change this up. I'm going to do an out parameter, int out prefix. Okay. Now, at the calling site, I'm going to pop back. I'm going to do address of prefix, and I'm going to create an integer up here, int prefix equals 0. Okay, so now what happens is this should flag whether it got a prefix or not. Let me just make sure it compiles. Oops. And then what I want to do is I want to set this to be the value of out prefix equals 1. Else, oh yeah, so then value of out prefix equals 0. And you know what? That logic is inverted. I would prefer to have positive logic first. So let's do that. Now that I'm doing a full if-else like I should. Okay, this is good design decision time here. Okay, recompile. That does that. Now what I can do is I can say if route, and then I can do if prefix. I can do prefix match. Else, oops, that's the wrong direction. Kick you in. And then do this. Okay, now let's try it again. Okay, let's see. Let's do slash prefix match slash exact match. There we go. So the code review and the testing manually confirmed that I can actually go and do an improvement to the design, because it would be important to know that you matched by a prefix versus an exact, because maybe you want someone to set a flag in a config file to say, hey, this handler handles anything with this prefix versus no, this handler is exactly just this match. All right. So that's the analysis. Me playing with it and everything is already done. Improving it. Collect all possible matches, then choose the longest one as the winner. That's another thing you could do. You could also find prefixes, and then use a regex to choose the winner. Extra credit, instead of just storing the string for the handler, create an actual engine that uses a handler struct to store the application. The structure would store the URL to which it's attached, the name, and anything else you'd need to make an actual routing system. So handlers, maybe you could load .so files. Instead of mapping URLs to arbitrary names, map them to .so files. Put these callbacks in your handler struct, and then you have yourself a fully dynamic callback handler system in C. That's actually a useful library. Maybe you should add that to learn C the hard way. That's the end of lecture 47. Thank you very much. Hold on and go over to lecture. I don't normally talk while I do code reviews, so remember, they go way, way faster, but the talking, I hope, shows you how I'm thinking and what I'm going through when I do them, and it teaches you a lot. Thank you very much. Welcome to exercise 48, where you do your first big project. This project is going to take from 48 until the end of the book. So you better make sure you got time to work on this. And it's probably it could take you a month, it could take you 2 months, it could take you a week. Just totally depends on how much effort you put into it, how quick you learn it. We're going to be making something called the stat server, okay? But the first exercise that we do, 48A, is just getting the stat server to answer a connection. So we just get a minimal first hack going, because that's the first step in any kind of programming. As much as people try to tell you that you have to create these perfect little projects in the beginning, it doesn't matter. Just get a little bit going and a little hack right in the beginning. That's your best bet, okay? In this case, what we're going to do is we create a simple network server that accepts connections on port 7899. And you can use NetClient that you made or NC. I'm going to use NC, okay? And you need to learn how to bind a port, listen to it, and answer it. So that's going to be the hardest part from this one exercise. The most important part of this project is just getting it up and running off a C skeleton. Don't worry about things like doing a daemon or any of that other stuff. You might even know what those are. Don't worry about it. Just run it from the command line. Okay, some clues. Well, the first biggest clue is I'm going to actually run my final version of it. So this is the server. See how I ran that? That's not how you do it in this exercise 48. Exercise 48, you just do this part. Just make it do that. Notice I picked a different port. Okay? And I'm going to do a little bit, I'm going to use NC. So here's how you use NC to talk to your server. And you're doing things like this. I'm going to do Z. Okay, and then sample Z, and then dump Z, and mean Z, standard deviation Z. Okay, but it's hierarchical. So if I want to say track the logins, I want to have a mean of means of all logins, then I can do this. Logins Z was on for 100 seconds. Logins Mary was on for 12 seconds. Sample logins Z 12 seconds. Sample logins Mary, say 156 seconds. And then what this means is the mean for Mary is how long she was on the server herself on average between all of her logins. But the mean of logins is the mean of means. So it's the mean of this and the mean of that for all logins. So now if I do dump logins, it shows me the means for all those logins. Or if I do mean logins, I have it there. You can also store logins. I believe that'll work. And then that will create a file. If we go over here, let me just abort. Now I have my storage, and actually I'll go over here, and you can see all I'm doing is I'm logging everything. See how I have that log going? And there's a weird file name in here for storage. Okay, and you'll see as we go on, see, it's got some weird stuff in it. So you'll see as we go on how you'll make all this. That's the end result. When you hit exercise 52, that should be what you've got. Okay, You should use libLC the hard way. We spent a whole book making that thing, so you're going to use it. Remember, you did a client already, so you can probably steal a lot of stuff from that net client project that you did in exercise 44. Do not use select. Okay, I was going to originally use select in the server, but I found it's too hard. So use fork instead. Go research what fork is. Keep it simple. Don't worry about anything other than accepting a connection and closing. And then stay small and build slowly. Remember, climbing mountains is easier than jumping over them. So climb it little bits at a time. Now, you're going to research online for an echo server in C. You're going to find out the majority of them are really terrible. So I'm going to give you some better references. There's a very generous book online called Beej's Guide to Network Programming. It's a free book online, similar to how mine usually are. And you can also purchase it. So if you appreciate it, please purchase it. This book also has, or this person also has another book called Beej's Guide to Unix Inter-Process Communication. I would almost read this book first and figure out all the code there, and then this book and figure out all the code there. I will warn you that some of his code is a little too far future, meaning that it's meant for IP version 6 in the future, but on my OS 10 machine, and I have the latest one, a lot of that didn't work. So you'll have to adapt. You'll have to get over sometimes stuff just don't work. A book that I found incredibly good and very similar to Learn Python, Learn C the hard way, but for network programming was Effective TCP/IP Programming by John C. Snyder. It's an older book, so it has the inverse problem of Beej's, where the code is a little too old. It should still all work, but you might have to adapt it. It only works with IP version 6, but it uses the very simplest stuff possible. The definitive sort of Bible of all of network programming is this one, Unix Network Programming by Richard Stevens, but Richard Stevens died, so there's some fellows and other authors. I'm actually not sure. Yep, Andrew and Bill Fenner. They basically maintain it for him, and they're now the maintainers of the book. It was pretty much the book I read first to learn how to do network programming. I would say only get this book if you plan on really doing a lot of this and you really like it. Get this book if you want to learn it and be sort of okay at the older style of doing it, but this is the basis of it. And read these books if you just want to get through this exercise. Okay, that's a lot of information. So the next thing you want to do, let me get my presentation back up, is do the man pages for accept, bind, listen, connect, select, socket, shut down, and fork. You should have fork. Make sure you know all those things. That's the constellation of it. Look at all the references, try to find sample code for all of that. Okay, here's the thing. This is going to be really difficult. The whole point of this exercise is to sort of knock off any lack of confidence with C. If you can get this project going, you can pretty much put together most C projects out there. This project should take you a while. Not just 48, I mean the entire rest of this book. It should be kind of hard, but it'd be really good for you. And on top of learning all about C and all the stuff I've been covering lately, you'll also learn the core of network programming, which is, fundamental to how computers work these days. This is really good fundamental stuff. So take your time. Remember, do it a little bit at a time. And then if you get super stuck, what I recommend is go watch 48B. My 48B video you see me go through it in sort of like a high-speed version of it, and I narrate it. Take notes, then attempt it again. And if you still can't do it, then go get the code from the Learn C the Hard Way lectures off of GitHub, and then that will teach you from the code how I did it. So it's all about just sort of like baby steps and figuring out how to do it a little bit at a time. Okay, that's the end of 48. I will see you at 48B if you get stuck. And you probably just want to watch that anyways to see how I did it different from yours. And then we'll go into 49.